Hello friends, today we are going to be learn MSBT Diploma in Electronics Group, third semester subject Linear Integrated Circuits, whose subject code is 22423. We have started from the first chapter, chapter 1, Fundamentals of Operational Amplifier, Op-Amp. I am Sachin Jagtai. Let us start with the outline. So in this topic we are going to be learn the introduction, operational amplifier circuit symbols and terminals, ideal differential amplifier, block diagram of typical op-amp, definitions of op-amp parameters, that is characteristics, voltage transfer characteristics, op-amp IC741, open loop and closed loop configuration of op-amp, concept of virtual short and virtual ground, dual op-amp IC747, and the questions based on all the above topics. So let us start with the introduction. First of all, let us understand what is linear and integrated circuit is. First, let us discuss about the linear circuit. Linear circuit is an electronic circuit in which circuit parameters are constant. The circuit parameters are like resistance, inductors, capacitance, waveform, frequency, gain, etc. So these linear characters or the linear components do not change their values during the operations. Or in other words, a circuit whose parameters are not changed with respect to current and voltage is called as linear circuit. So in which circuit, if the voltage changes, the current is also going to be changed. If the voltage is increases, current is also increases. If input it changes, output is definitely going to be changed. That circuit is called as linear circuit. As an example, here in this circuit, the resistance and inductors are connected with the voltage source, and as per the characteristics, as the voltage increases, current is also increases linearly. So this is called as a linear circuit. Now let us understand what is integrated circuit is. So integrated circuit is an electronic circuit formed on a small piece of semiconducting material which performs the same function as a large circuit made from discrete component. So that means if we are designed or we have developed a amplifier, whatever the amplifier is performed, the same amplifier can be performed by a small device which is called as an integrated circuit. So let us consider this is my discrete circuit. In this discrete circuit, there are many components are present, that is resistor, capacitor, inductor are present. And if I am repetitively using these circuits in different projects or in different applications, so every time I have to mount all these components and again I have to test whether they are functioning or not properly. So rather than that, if I am using the same circuit every time repetitively, why should not make that whole circuit placed in a small IC format, that is called as an integrated format, and that is they had said as a semiconducting material platform. So what we have done, we have replaced this discrete circuit into an integrated circuit, that is called as a ICs. So all the circuit, whatever the circuit is going to be performed earlier, the same circuit or the same operation is performed by this ICs also. So if we are performing the same operation by this IC, then we are directly not for manufacturing or not performing any complex circuit anymore. Directly we are using ICs to perform their operations. Let us continue understand where it is being started and why it is called as an op-amp. One electronic device which can be used to construct the following applications or circuit is called as an operational amplifier. If any one of the IC is performing all the below operations, that IC is called as an operational amplifier. So it is performing as like as amplifier. It can be act as a active filter. Arithmetic circuits like addition, subtraction, multiplication, division, integration, derivations. Similarly, that circuit can be performed as a voltage comparator, waveform generator, precision rectifier, multipliers, time multivibrator, log and anti-log amplifier, regulated power supplies, etc. So all these operations can be performed on single ICs. So that IC is called as operational amplifier. So it is performing many operations at a time. So due to that one, it is called as an operational amplifier. So where it is being started, so first of all, the term operational amplifier or op-amp was first used by John Riggini in 1947. Initial days, op-amp were being extensively used in analog computers. As we already discussed, its op-amp is having an application of arithmetic circuits like performing addition, subtraction, division, multiplication. So it is also being preferred in analog computers those days. The first op-amp in the integrated circuit, that is called as the IC form, was brought in the market by Fairchild Company. The named this IC op-amp as mu A741. Op-amp is basically a multi-stage amplifier which uses a number of amplifier stages interconnected to each other in a complicated manner. So there are different stages are interconnected with each other. There is not a single amplifier. There are many stages are connected to each other. Let us see the advantages over the conventional amplifier. So first of all, its first advantage, it's smaller in size. Its reliability is higher than the conventional amplifier. It reduces the cost as compared to its discrete circuit counterparts, less power consumption, easy to replace, and same op-amp can be used for different applications. So these are the advantages of op-amp. Now let us see the next, that is operational amplifier circuit, symbol and terminals. So first of all, this one is the symbol of operational amplifier. As per the symbol, it's a triangular shape. In triangular shape, that arrow direction indicates the conventional current flowing direction, whereas it's having two input terminal. One input terminal is called as inverting, which is indicated by minus sign. Another input terminal is called as a non-inverting, which is indicated by plus sign. Similarly, it is again having two more input supply terminals. One is positive VCC, another is minus VEE. So it's a dual power supply requirement. This IC is required dual power supply, or some of the ICs required a single power supply also, but most of the time we are using a dual power supply IC741, and one last as a one output terminal. So as looking at the symbol of op-amp, we directly recognize it is having two input and one output terminal. So definitely let us see the different inputs and output signals of op-amp. When we applied a sine wave to an inverting amplifier or inverting terminal, that time the output will be inverted, and when we are applying a sine wave to a non-inverting terminal, then output is amplified but it's not inverted. So that means in inverting, the output is always 180-degree phase shift with respect to input, but in non-inverting terminal there is no phase shift. Now let us see the IC741 op-amp. It's IC741. It's a 8-pin IC. We will discuss this IC package in detail in next section. Now let us study the ideal differential amplifier. Ideal differential amplifier. Here is the circuit which indicates a differential amplifier. It's a BJT differential amplifier which is having two BJT, and this 2 BJT is having two different inputs, that is Vin and Vin2. Similarly, two outputs at collector. From first BJT there is a Vout1, and from another BJT Vout2. So whereas when these two collectors are gives, the single output is nothing but a differential output. So whatever the input is applied, according to that one, we are getting at this point as a differential output. Let us see how it happens. An differential amplifier is expected to amplify the differential signal present between its two input terminals. So two input terminals are nothing but Vin1 and Vin2. The operational amplifier is basically a differential amplifier. This operational amplifier is called as basically a differential amplifier. The input signal V1 and V2 are differential signal Vd. So Vd will get at Vout1 and Vout2, where it meets, we will get a differential signal Vd. Differential signal Vd is always equals to V1 minus V2. The differential amplifier produces a zero output if voltage V1 is equals to V2. When both the inputs are same, we are getting zero as the output. So this amplifier will amplify only the difference V1 minus V2 between the input signals. That's why it's called as a differential amplifier. Let us see the common mode signal and gain of it. So a common mode signal to both the input terminals V1 is equals to V2 is equals to V is called as a common mode signal. The output voltage produced by ideal differential amplifier is 0 for the common mode signal. VO is equals to AD V1 minus V2, where AD is called as a differential gain. So for now, this is a differential amplifier, we should have a differential gain, and so we will consider it's a constant, that is AD. It is our constant, that is a gain of differential amplifier. And now the output voltage is nothing but VO is equals to AD into V1 minus V2. Now the differential signal VD is nothing but, that is our differential signal V1 minus V2. So we can replace VO is equals to AD into VD. So that is differential voltage into differential gain. So the differential gain is nothing but AD is equals to VO upon VD. So instead of defining it as a ratio of differential gain, is sometimes expressed in decibel. So we are representing in a decibel, that is dB, as AD dB is equals to 20 log to the base 10 VO upon VD. The gain for IC741 is typically 2 into 10 to the power 5 or 10 to the power 6 dB is always. So it's very high gain of IC741. As we said, we are using a IC for operational amplifier, and that IC name is IC741, whose gain is very high, which is always constant, 2 into 10 to the power 5. Now let us understand what are the different types of differential amplifiers. So types of differential amplifiers are: first, it's a dual input balance output, dual input unbalanced output, single input balance output, and single input unbalanced output. So if the input signals are applied to both the inputs, then the amplifier is called as dual input signal amplifier, and if the input is applied to only one input, then it is called as a single input amplifier. So when both the inputs are applied, then it is called as a dual input, and only one input is applied, then it is called as a single input amplifier. Similarly, if output is taken between two collector terminals, then it is called as a balance output, whereas if it is taken with respect to ground, then it is called as a single ended output, or we can say it's an unbalanced output. Now let us understand with the block diagram. So block diagram of typical op amp. This is the block diagram of typical op amp, whereas the triangle is indicating the current flowing direction. We are applying two inputs, inverting and non-inverting. Then it's having two dual power supply, VCC plus VCC and minus VE. So there are four different stages in the block diagram. First is the input stage, second is the intermediate stage, third is the level shifting stage, and fourth is the output stage. First two stages is nothing but a differential amplifier, because it is having two input and one output. So let us see that first input stage is consisting of a dual input balance output differential amplifier. Second, intermediate stage is nothing but dual input unbalanced output differential amplifier. Third is the level shifting stage. It's an emitter follower using constant current external source. Fourth, output stage is a complementary symmetry push-pull amplifier. Let us study block diagram in detail. Its working. Let us understand. Let us understand the working of block diagram in detail. So there is first block, that is called as input stage. The input stage is a dual input balance output differential amplifier. The two inputs are inverting and non-inverting input terminals. This stage provides most of the voltage gain of the op amp and decides the value of input resistance Ri. So this stage is defining the input resistance value of Ri. And second stage is the intermediate stage. This is usually another differential amplifier. The input stage derives this stage. This stage is a dual input unbalanced output, that is a single ended output differential amplifier. Then third block, that is a level shifting stage. Due to the direct coupling used between the first two stages, the input of level shifting stage is an amplified signal with some non-zero DC level. Level shifting stage is used to bring this DC level to zero voltage with respect to ground. So whatever the non-zero value is there, we need to be adjust to the 0. So this stage is going to be adjust the value of differential amplifier to the 0. And the last stage is output amplifier output stage. Last is the output stage. This stage is normally a complementary output stage. It increases the magnitude of voltage and rise the current supply capability of op-amp. It also ensures that the output resistance of op-amp is low. So this much is about the block diagram of op-amp. So today we have discussed about introduction, operational amplifier circuit, symbols and terminals, ideal differential amplifier, block diagram of op-amp. In next video we will discuss about definitions of operational parameters, that is characteristics. Thank you.